Hey guys, in this video I'll explain about simplifying algebraic fraction. So before you learn about this, you need to master these four things first, this four concept, before proceeding with this topic. If you haven't mastered this, I suggest that you go back to the previous video that I made and come back here if you have mastered that. Okay, so these are the four things that you need to understand. The first one is exponent rules, and then the second one is factoring and expanding brackets in algebra, of course, and then arithmetic operation involving fractions, and the last one is simplifying fractions. So these four are the things that you need to master before you go to this topic. Okay, so I'm gonna jump into the examples here and how to simplify algebraic fraction. So here, sometimes we get a question like this, and we need to like simplify this fraction. It's the same thing like if you simplify a fraction. Let's say I have like 3/6. I can simplify that becomes 1/2 because like these two things, these two numerator and denominator, both of them are divisible by 3, right? It's divided by 3, you get 1, and divided by 6, divided by 3, you get 2. So basically the same concept applies here, and actually you can just like cancel them. If I have like 3 times 2 over like 3 times 5, you can just cancel the 3 and 5, right? So it just becomes over 5. So this concept is going to be very useful in order to simplify algebraic fraction. So I'm gonna jump to the first example here. I have this as an example: 15a to the power of 5 b to the power of 6 over 24a to the power of 3 b to the power of 9. So basically what we're doing here is just simplifying the terms in which we can just cancel them, right? Like but just make sure that all of them are being multiplied. So that here 15 a to the power of 5 b to the power of 6, all of them are being multiplied, and that denominator 24 a to the power of 3 b to the power of 9, all of them are also being multiplied. So just cancel the numbers that we can cancel, like 15 and 24, because this 15 and 24, both of them are divisible by 3. So just divide by 3, you will get 5, and divide this by 2, you get 8, right? So that is going to be 5/8, like that. Okay, and then this the next one, in exponent rule, we have learned about quotient rule, right? So if we have like the same base number, right, like this one here, a with a, this guy, right? So what you need to do is just like subtract the power, right? The numerator power with the denominator power. So it's going to be a to the power of 5 minus 3. Okay, so that is going to be for the a's. And then the next one is for the b. Here we have b to the power of 6 divided by b to the power of 9. So it's going to be b to the power of 6 minus 9. Okay, so we only need to subtract these. So we have the 5 and the 8 doesn't change, right? So the 5 and 8 doesn't change. But the a now is going to be to the power of 2, because we know that 5 minus 3 is 2. And the next one is b to the power of 6 minus 9 is going to be b to the power of minus 3. Okay, so actually this is already finished, but most of the time we need to make the power so that it will become positive. So this power is still negative, right? So again, in exponent rules, if we have like 1 over, it should be a to the power of n. It should be, if I have a to the power of minus n, it's going to be equals to 1 over a to the power of n. If I have like 2/3 to the power of like minus 2 example, it's going to be 3/2 to the power of 2. So you see that this power here, negative becomes positive by just like changing, like swapping the numerator and the denominator. Okay, so for this case then, so it means that I'm going to make that so the b from numerator becomes denominator, so that it will be positive power, right? So it's like 5/8 doesn't change, and then the a to the power of 3 doesn't change, because again the a has a positive power, and then the b here is going to be going down or going to the denominator, so it's going to be b to the power of 3. So here we go, this is the first example. Okay, the second example here, we have 2x plus 2 over x plus 1. So some of my students do this like in past a couple of years, and then just like, oh, I can just cancel this. Okay, don't do it, okay guys. Why? Because it's not, this guy is like these terms are being added or if being or is being subtracted. If you see that there is still like plus or minus and it's not the same term, you can't just cancel it. Okay, so don't do that. Okay, so again, like I said before, what you need to understand is how to expand bracket or to factorize. And here, we actually can factorize that 2x over 2x plus 2, right? So it becomes 2x plus 1, right? That this guy here, right? You can factorize like that. So and in the denominator we have x plus 1. I can just like add a bracket, so make to make it very clear that is these like it's like 1 times this, right? So I don't need the 1 actually, but I'm gonna put 1 here so to make it clear that we're actually multiplying, right? So 2 times this and then 1 times this. And then as you can as I said before, guys, when you're simplifying fraction, this is like I have like 3 times 5 over like 3 times 2. I can just like cancel this 3, right? Because they are being multiplied. So if they're being multiplied, you can just like cancel the numbers, right? So for this one here, this x plus 1 and x plus 1 here inside the bracket, they are exactly the same. So I can just like cancel these two, and then I will get only 2 over 1 or equals to 2. Okay, as simple as that. Okay, so the next example is actually the same for this one, but this one is going to be an what they call it, quadratic equation, right? So what you need to just like factorize, right? You can't just like cancel this and then cancel the x. No, you can't do that, because again we have like this addition, right? Or if it's subtraction, it's the same thing. But if they're being multiplied, like this guy over here, right? So you can cancel it. Okay, so the first thing that we need to do is to find out whether these two expressions on the top, which is the numerator and the denominator, can be simplified. Oh, sorry, not simplified. It can be factorized. So if I write it down like this, guys, in factorization in my previous video, this guy can be factorized as x plus 2 times x plus 3. Okay, so if you don't know how to do it, again, go back to my previous video in how to factorize a quadratic expression like this one. So basically it's just like this. You find two numbers that can be multiplied equals to 6. So this is like 2 times 3, right? And then actually we have another like numbers which can be multiplied equals to 6, which is 6 times 1. So we have these two pairs, right? So from these two pairs, which one, if you add the two numbers, equals to this number here, right? So 6 plus 1 is 7, right? This is not 5. But 2 plus 3 is equals to 5, right? So this is going to be matched. This is where I get the 2 and 3. Okay, so I'm going to erase that. Okay, so the same thing if the same thing for the denominator. So let's find out how we can factorize this expression, right? So we get 10. I can get it from like 2 times 5, right? 2 plus 5 is equals to 7. Oh, it matches. So it means that I can write this down x plus 2 and x plus 5. Okay, so the same thing, guys, because this is like this guy is multiplying with this guy and on the numerator, and this guy is being multiplied with this one as the denominator. So if I see that we have the same exact factors, we can just cancel, right? So this is x plus 2 and this is also x plus 2, right? Since they're exactly the same, I can just like cancel these two, and I leave that with x plus 3 over x plus 5, and I can just like write it down as the final answer. So x plus 3 over x plus 5. You don't really need the bracket anymore because I mean we don't need something else, like it doesn't have any other number on the like outside the brackets, right? So this is going to be the final answer. Okay, another example here. Okay, the next example is going to be an operation of arithmetic operation of fraction, right? Like addition, subtraction, multiplication, and division. Okay, so remember in when adding or subtracting fraction, what you need to do is to make sure that they have the same denominator. If they have the same denominator, then you can just add or subtract the numerator. So let's say I have like 3 over 4 plus like 5 over 4, right? Because both of these fractions has the same exact denominator, so I can just like add 3 plus 5. 3 plus 5 is 8. 8 over 4, right? Or I can simplify this 8 divided by 4 is equals to 2. But if I have different, like let's say I have 1 over 3 plus 1 over 2, this cannot be like added like straightly like this 2 over 5. No, you can't do this because it doesn't have a same denominator. So what you do is like you can do it like this, guys. Find the LCM of 3 and 2, which is 6, right? And then you change this into like the equivalent fraction in which the denominator is 6. So we know that 3 becomes 6 is just multiplied by 2. So this is like multiplied by 2, you get 2. And this guy multiplied by 3, and this guy multiplied by 3, you get 3. And then you just add because you have already matches. I mean, like the two fraction that we're adding has the same exact denominator, so just add the numerators. 2 plus 3 is equals to 5. Something like this, okay? And then maybe another way how to do this is like this. I have like 1 over 3 over 2. I can just like cross multiply this 2 multiplied by this, it comes 2, and this 3 multiplied by 1 is 3 because this is like adding, right? So and then well for the denominator this is like multiplying these two denominator, we get 6, and then you will get the same answer. Okay, so this is the example of how to add and subtract fraction. Okay, you do the same thing in algebra. Well, don't be confused with the x's. It's the same thing, the same concept. Okay, guys. So in here, again, the first thing you do is to make sure that the denominator are the same. Here, we have the same exact denominator, so you only need to add the numerator, right? So it's addition. X plus 2x is 3x, and then the denominator doesn't change. And then we can simplify this by, because we know that 3x is 3 times x over 3, you can just cancel the 3 and you will get just x. Okay, the next thing is this one here. So I'm going to do it like this one here, right? So I'm gonna like, sorry, I should write it. So I'm gonna do that and try to multiply like this. 4 times 2x is going to be 8x, and then 3 times 3x is going to be 9x because this is addition, so this is plus, and then 3 times 4 is going to be 12. Okay, so 8x plus 9x is 17x over 12. Since 17 and 12 doesn't have any other factors besides 1, so this is going to be the final answer. Okay, quite easy, right? Okay, the next thing is this one. This is actually the same. Again, like I said before, you only need to make sure that the denominator are the same. In here, we have the same exact denominator, right? So what you need to do is just like add and subtract all the numerators. We have 8 plus 3 minus 2. 8 plus 3 is 11. 11 minus 3 is just 9. So it's 9 over x, and then you're done. Pretty easy. Okay, the next one is this one, 5 over 6x plus 3 over 2x. So actually you can do it like the cross multiplication, or you can just like find the LCM of 6x and 2x, which is 6x. Right, so 6x becomes 6x is just like multiply by 1, right? So you do the same thing, multiply by 1, you get 5. And for this 2x becomes, sorry, this should be 6x. 2x becomes 6x, you multiply by 3, so this guy is also multiplied by 3, you will get 9. So we get 5 plus 9 is going to be equals to 14 over 6x, and then you can simplify this 14 and 6 by dividing that by 2, you get 7 over 3x. And remember that this x doesn't move to the top, okay? So it's being in the denominator, so don't change it. Okay, so what if I use the other method, like the cross multiplication? So I'm going to rewrite that again. Question. We have 5 over 6x plus 3 over 2x. Okay, so if I do it like that, like this one, 2x times 5 is equals to 10x, right? And then we have 6x times 3 is equals to 18x. And then you multiply these two, I'll get 12x squared. I'm gonna write down xx, okay? So to make it sure, to make you understand on how to like what they call it, canceling numbers, okay? So if I have that, we have 10x plus 18x is equal to 28x, and then that is going to be 12x times x. Okay, like I said before, if we have the same exact factors, right? So you can just cancel, okay? So that x we can cancel, right? This x and this x, right? And then that 28 and 12, both of those numbers can be divisible by 4, right? Divided by 4, you get 7. Divided by 4, you get 3. And then you will get 7 over 3x. Right, so leave 7 on the numerator and then 3x as the denominator. As you can see, you will have the same exact answer. Okay, next example here, I have 4 over x plus 1 minus 3 over x plus 1. Again, don't be confused, right? So the first thing that you need to make sure is that you have the same exact denominator. If you have it, it's going to be very, very easy, right? So as you can see that these two fractions have the same exact denominator, so you don't need to change anything. So you only need to add or subtract the numerator. Here we have 4 minus 3 is just 1, right? And the denominator doesn't change, and you're done. As easy as that. Okay. And the next one here, what if we don't have the same? Okay, so for this kind of questions, I prefer that you do like the cross multiplication, right? So this times this, and then this times this. Okay, so let's do that. So x plus 1 times 3, I can write it down as this, right? And then added with, because this is an addition, so added with this times this, we have 2 bracket x plus 2, and then the last one, and the denominator is just like multiplying this one and this one. We have x plus 2, and don't forget the bracket sign, x plus 1. Okay, so you only need to expand the bracket, right? So 3 x plus 1, we have like this guy is being multiplied. It's like distributive properties. We have 3x plus 3, right? And then plus this one is 2 times x is 2x, and then this 2 plus 2 2 times 2 is plus 4. And then this one you do it with FOIL. This times this is going to be x squared, this times this equals to x, this times this equals to 2x, and then this times this is going to be equals to 2. Okay, so simplify. If you have like terms, you combine them, like 3x and 2x becomes 5x, right? And then 3 plus 4 is going to be 7, and the denominator we have x squared, and then these two numbers, 2x plus 2x is going to be 3x, and that's going to be plus 2. So this is going to be the final answer. So you can just like do it like that. If I write down for you guys the general, what do you call it, formulas for using the cross multiplication like that. If I have like a plus b added with c over d, it will be equals to ad plus bc over bd. Okay, so this is the main concept that I'm using to do this question over here. Okay, so just multiply this times this, right, becomes ad, this times this becomes bc, and then this times this becomes bd. Okay, so that is the general formula. Okay, we have done for the addition and subtraction. Now we go to the multiplication. So multiplication and division is a lot easier than addition and subtraction, right? Remember, if I have like 2 over 5 multiplied by 3 over 4, let's say, this is just like multiplying the numerator with the numerator, with denominator with the denominator. So I have 2 times 3 is 6, now 5 times 4 equals to 20, and I can simplify that by dividing both them by 2. I divided by 2, get 3, divided by 2 equals to 10. So here we go, right? As easy as that. Okay, so again, it is the same thing with this one. You only need to divide. You need to multiply, sorry. But if you have something that you can, what do you call it, simplify first, you can simplify it, right? So if I write down like this, guys, if I write it down like this, I'm gonna move that 5x to the like, so this is equals to like x plus 1, right? Multiply by 5x, and then 3x multiplied by 2x plus 2. Okay, so in here, so you can actually like multiply all of them, but I prefer to do it like this. If you see that, because all of them are being multiplied, that 5x is 5 times x and 3x is 3 times x. That's because we have the numerator and denominator is like being multiplied by that x. I can just cancel that, or I can write it like this. If I want to factorize this first, right? So I will get, sorry, for the x plus 1 is still x plus 1. I'm going to move the 5x to the front, right? So it's like 5 times x, right? And then you times it with x plus 1. I'm going to rewrite it like that. And then that 3x is just 3 times x, right? And then I'm going to factorize that 2x plus 2 becomes 2 bracket, I'm going to write down with this one, 2 bracket x plus 1, okay? Factorizing this becomes this, okay? So again, if you're still confused on how to factorize, go to my previous video. Okay, so in here I can cancel, right? So which one do we can cancel? Okay, so in here we can cancel the x, right? Because again, this is being multiplied, and we can also cancel this one with this one, right? So that leaves only 5 on the numerator and 3 times 2 as the denominator, and then you get the final answer. As easy as that. Okay, the final example for this topic is this one here. So again, basically you do the same thing. If you can simplify first, okay? And then again, if you still remember on how to divide fraction with fraction, so you do it like this. If I have like a over b divided by c over d, this has become a over b multiplied by d over c. So you only need to change this into like multiplication, and then swap the numerator and the denominator. Okay, so let's do it. So we have 3x minus 9. I'm going to I'm going to factorize that. It becomes 3 bracket x minus 3. This guy, okay? And then that 5x plus 5, I'm gonna change that into 5x plus 3. Okay, of course you cannot cancel this one and this one because it's different, because that one is like minus 3 and this is plus 3. You can't just cancel that. But in here I have, because it's like division, change it to multiplication, and then just swap these two, right? So I get x plus 3 over x minus 3. I can add like a bracket if you want to make them like easier to see. If I combine that, I will get 3 bracket x minus 3 times x plus 3, right? This guy is being multiplied with this guy, right? Because this is just a multiplication, so you don't need to like finding the same, or I mean like to make sure that the denominator are the same. You don't have to do it, just multiply, and then over 5x plus 3 and then x minus 3 again, because they are being multiplied. And then if we see that we have the same exact terms or expression, you can just like cancel, right? As long as they are being multiplied. Okay, this is multiplication, and this one we cancel with this one, this one we cancel with this one, so it only leaves 3 over 5. And there we go, we have the final answer.